Okay, to solve this problem, in problems like this, you need to find the voltage across and the current through each of the elements that are shown. And so the idea is you can use KVL and KCL to find things that are not known. All right, so let's start. I'm looking here, I don't know voltage VB, and so I can make a reference signal here, plus minus VB. You know, you can put that however you like in terms of the polarity. But I did it like this, and so then I can write a loop equation, and so I'm going to go in this direction. So I have a rise of VB, and then I have a drop of 30 volts. So rises are equal to drops. Rise of VB is equal to a drop of 30 volts, so VB is 30 volts. Okay, then I can do the same thing with VD. Okay, so I don't know this voltage, so I'm referencing this plus minus VD, and I can write a loop starting here. I'll go in this loop. I have a rise of VD, then I have a rise of VB, so rises on one side, and then continuing on, I have a drop of 20 volts, and that's it. So equal 20. All right, so VD is equal to, in this case, 20 minus VB, and VB was 30, so this is minus 10 volts. Okay, it's okay if it turns out to be negative. All right, so going from there, we can figure out the power for everything else in this circuit. Okay, so noticing the current here for element A, this is 2 amps moving this way. That was given from here. All right, so I have for VA, power is going to be 2 times 30. All right, so that's going to be 60 watts. And then I just have to determine, is this using power or supplying power? Okay, so since this is moving in the direction of a drop, okay, 2 times 30, 60 volts. Since it's the passive sign convention, this would be supplied. Okay, all right, for VB, all right, I have to determine the current for VB. I can use KCL for that because I have 4 amps coming here based on that, and 2 amps coming here. And so this current is, the current coming out is IB, and it's equal to the sum of the 2 currents coming into that node, which would be 2 plus 4. So IB is equal to 6 amps. Okay, so we already know VB is 30. Okay, so 30 times 6 is 180 watts. All right, and then this is the active sign convention because current, as I have it referenced here, is moving in the direction of a voltage rise. Okay, so because it's the active sign convention, this is, oh, I said this one backwards. This one is, it's a passive sign convention, so it'd be 60 watts used. Okay, this one's the active convention. This would be 180 watts supplied. So sorry about that mistake. All right, then we look at C. For C, I have 4 amps moving in the direction of a voltage drop. All right, so that's the passive sign convention. This is 80 watts, 4 times 20. And since it's the passive sign convention, this is power that is used. Okay, so VD is a little trickier. All right, so with VD, I have 4 amps, and the way I have this referenced here is minus plus. All right, so the 4 amps is moving in the direction of a voltage rise. Okay, so this would be the active sign convention. Okay, so 4 times 10 is going to be, well, it's actually minus 10. So it's minus 40 watts supplied. But minus 40 watts supplied is the same thing as 40 watts used. Okay, so then we just need to check our math to make sure everything balances in terms of conservation of energy / power. Okay, so I'm looking at 180 is on the supplied side. I add up the used, all right? So I have 60 plus 40 plus 80, that's 180 watts on the used side as well. So you see these balance, and I'm pretty confident about my answer.